Okay, we're now ready to go through the worked examples on the laws of indices. We're using applications of the laws of indices to simplify expressions. So we're going to go through worked example 2.1, and I believe it goes up to 2.5. Yeah, we'll go up to 2.5 in this video. So definitely, right, if you didn't watch the last video on, and you need to, on the laws of indices, watch that. Otherwise, this may be a little bit confusing. Anyway, let's begin. So example number 2.1, let's go through it. So simplify 3xy times by 8x, y to the power of negative 2. I'm going to go through this in detail, okay? So let's kind of break this into its long form. So 3xy really means you're doing 3, you're timesing it by x, you're then timesing it by y, you're then timesing this all by, okay, 8 times by x times by y to the power of negative 2. And then what you can go and do here is consider your number parts. Okay, so you've got a 3 and you're timesing it by an 8. Okay, 3 times by 8 is 24. And then you're timesing this by, if we look at the indice parts for x, you've got x times by x. Okay, laws of indices, if you're timesing with the same base, you add the powers, you can't see it. X is the same thing as x to the 1, so x to the 1, you're timesing them, add the powers, 1, add 1 is 2. So you've got timesing it by x to the power of 2, you're then timesing it by, last but not least, you've got y times by y to the power of negative 2. Okay, so you've got y to the 1 times by y to the minus 2. Laws of indices, you add the powers, 1 and negative 2 is minus 1, so y to the power of negative 1. So timesing it by y to the negative 1. So overall, okay, of course we can simplify this, because if you're timesing things together, you can just write it as one thing, which is going to be 24 x squared timesing it by y to the power of negative 1. If you wanted to, you could write it either as this, also 24 x squared, y to the minus 1, okay, we know, right, means 1 over y. So if you wanted to be fancy about it, you could write it over y. But I think in the book, they're probably going to be writing it like this. So I'm going to stick with this being my answer. But this also means exactly the same thing. Okay, good. So broke it down so we can really see what was going on there, hopefully. Example 2.2 is this. Simplify this thing here. And what I'm noticing is, right, if you're taking away stuff with indices, it isn't particularly useful, because the laws of indices are all about timesing things together or dividing. So what I'm going to go and do here is split up my fraction into two parts, okay, which is going to be this. The first part, which is 12a squared b, I'm going to divide it by 3ab, okay, and then I'm going to take away my second part of the fraction 9ab cubed and divide it by 3ab. If you're thinking, why is that the case? Why can I do that? Okay, if you've got something to, I always think, right, why are we allowed to do this? Use a really, really simple example. If you've got something like 4 add 6 and you were dividing it by 2. So what I've really done here is I've kind of replaced this here with 4, this part here with 6, and really to make it, consistent, that should be a takeaway sign. So takeaway divided by 2. Okay, so this 2 is going to be representing this part here. Right, 4 take away 6 is negative 2 divided by 2 is going to give me negative 1. And it's the same thing as doing 4 divided by 2 take away 6 divided by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. 2 take away 3 also gives me negative 1. So when you have a fraction like this, you can split it up into two parts. Okay, so it's always a good idea if you need to kind of think about something using a simpler example. That's a good thing to do. Anyway, I digress on that. Okay, let's look at this first part over here. So if we go and look at, well, what's 12 divided by 3? To begin with, 12 divided by 3 is equal to 4. We've then got a squared divided by a to the power of 1. We are dividing here indices with the same base. Okay, you can take away the powers. 2 take away 1 is 1. So it's going to be a to the power of 1, or just a. You've then got b to the power of 1 divided by b to the power of 1. Okay, b to the 1 divided by b to the 1. Take away the powers, you get a 0. And we know that anything to the power of 0 gives you just the number 1. So you could write 4a1 if you wanted to, but 4 times 1 is just 4, so you just write it as this, 4a. We are then taking away, okay, 9 divided by 3 is going to be 3, so 3. You've then got a to the 1 divided by a to the 1. Take away the powers again, going to give you a to the power of 0, which again, anything to the power of 0 is just equal to 1. So that's going to go to 1, which you can just leave it as it is, that's fine. You've then got b cubed divided by b to the 1, take away the powers, 3 take away 1 is 2, so we get b squared. So 4a take away 3b squared is the answer. Okay, hopefully that made a bit of sense. Good. 2.4, this one here is saying solve this. So you want to find the value of x. So x to the power 4 over 3 is equal to 1 over 81. Now, if you wanted to solve something like this, the square root of x was equal to, I don't know, 5 for example, okay? Or to solve this, you need to get rid of the square root on this side, and you would do that by doing the opposite of a square root, which is to square both sides of the equation, because then these would cancel and you would be left with x being equal to 5 squared, which is 25. So this is the idea behind this question. Okay, if we get rid of this over here, so we've got x to the power of 4 over 3 being equal to 1 over 81. Now to get rid of this 4 over 3, because when you solve something you want to isolate the missing variable, which is x, on its own. To get that on its own here, what's the inverse of doing the power of 4 over 3? It is to multiply both sides by the power of 3 over 4. Okay, so put both sides to the power of 3 over 4. And the reason is, right, what's 4 over 3 times by 3 over 4? It cancels to 1. Right, let's make sure we understand that. We've got 4 over 3 times it by 3 over 4. Okay, well, 4 times 3 times the fractions on the top is 12. 3 times 4 is 12. They cancel, they give you 1. So these are going to cancel, okay, cancel away, which is good. So you're left with x being equal to, you then got this over here. And we learnt from the previous video, right, fractional power means you're rooting. So we are rooting 1 over 81. The root that you take is the denominator of the fraction, so the 4th root, and then you put all of that to the power of your top number, which is 3. There we go. So the 4th root of 1 over 81, well, the 4th root of 1 is just going to be 1 still, because 1 times 1 times 1 times 1 is 1. And then what is the 4th root of 81 going to be? What number times by itself? 4 times is 81. It is 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. So 1 over 3, and then of course you're raising that to the power of 3. And this means you've got 1 over 3 times by 1 over 3 times by 1 over 3. So you've got 1 times 1 times 1, which is 1, 3 times 3 times 3, which is 27. So 1 over 27, that is your answer. Okay. Ooh. Did I miss a question out here? I have. That's really strange. Right. 2.4. I've missed out question 2.3, haven't I? That's very strange. What I will do is I will write it up at the end. Apologies for that. I've just missed it out completely. You know what I'll do is, right, let's scroll down and let's do it below here. Sorry about that. So question 2.3, don't know why I did that. I think I might have, not sure what's happened. Sorry, it's 2.3 is saying this to simplify, write root x over 5 root x cubed. Write it in the form. Hopefully you've got your textbook in front of you and this is making a bit of sense, but k x to the power of p. Okay, so this one, right, let's break it down. Root x, how can we go and write root x to begin with? Well, hopefully we know that root x is the same thing as x to the power of 1 over 2. They mean the same thing. So the first part we can write as x to the power of 1 over 2. And that's all over 5. And then we've got this part over here, the cube root of x. So the cube root of x we can write as x to the power of 1 over 3. So we've got 5x to the power of 1 over 3. And then we can go and consider doing x to the half divided by x to the third. Okay, so what is x to the 1 over 2 divided by x to the power of 1 over 3? Same base, we can take away the powers. What I would do here is I would get the fractional parts to have the same denominator, so that's going to be 6, so a half is the same thing as 3 over 6, and we're dividing it by, and then a third is the same thing as 2 over 6, so 2 over 6. Now we can take away the powers, so x to the power 3 take away 2 is 1 over 6. So we're going to be getting these parts here. We'll go to x to the 6. Okay, so x to the power of 1 over 6. And you've still got this kind of being divided by 5, so over 5. Or you could write it as 1/5 x to the power of 1 over 6. They mean exactly the same thing, and the book's probably written it as like this, I'm guessing, which it has. Okay, good, but they both mean the same thing. Okay, this and this, they both mean exactly the same thing. Okay, good. Sorry I messed up that question. That was pretty silly. We've done this one. Good. So on to the last one, I believe, which is 2.5, which is to solve this. Yeah, last one. Okay, good. So we want to solve this equation, right? So you want to find the missing variable x. Now, if you're trying to find the missing exponent, the missing power, you want the bases to be in terms of the same number. So you've got to think, well, you've got 2, 8, and 4. How can you write them in terms of all of the same base? Write them in terms of 2. Because, well, 2 is already 2, which is good. 8 we can write as 2 cubed, and then this 4 down here we can write as 2 squared. So 4 can be written as 2 squared, and you'll see why this is really, really useful in a second. So let's kind of rewrite the equation. We've got 2 to the power of x times by 8 is the same thing. I'm going to write it in a bracket as 2 cubed, and that is being risen to the power of x take away 1. Okay, and that's being equal to 1 over 4 is the same thing as 2 squared. Okay, I've just put it into a bracket, and that's being risen to the power of 2 over x. And now let's just kind of use our laws of indices here. So the first part, we've got 2 to the x, we're timesing by. Now, the power law, we can go and do this 3 times by this x take away 1, and let's put this into a bracket so we don't kind of miss anything out. It's going to be 2. 3 times x is going to be 3x. 3 times by the negative 1. Okay, this times by the negative 1 is going to be negative 3. So take away 3 is equal to 1 over, again, power law, 2 times by 2x is going to be 4x. So it's going to be 2 to the power of 4x. Okay, and let's just scroll down a little bit and rewrite this again. So we've got 2 to the power of x times by 2 to the 3x take away 3 is equal to, now this part here, right, 1 over, right, whenever you see 1 over, you can write it as your number, which is 2, negative power to the power of 4x. Okay, this is your negative power law. Okay, right, and what we can do now is we can notice, right, we've got the same base, we've got a 2, and a 2, and we know, right, if you're timesing indices with the same base, we add these powers, so we can add x and 3x minus 3 to be equal to this. Okay, similarly, if you had something like 2 to the third times by 2 to the 7, right, you would add together the 3 and the 7 to give you to the power of 10. We're doing the same thing here. So we're going to be doing x, and we're adding to it 3x minus 3 to give us negative 4x. And then we've got to just go and solve this equation. So x at 3x is going to give me 4x take away 3 being equal to negative 4x. And I'm going to go and add a 4x to both sides, because then these guys are going to cancel. So I get 8x. I'm going to bring the negative 3 onto this side to give me equal to 3. So x divided through by 8 is going to be equal to 3 over 8. Okay, by dividing through both sides there by 8. Dividing by 8, there we go. Okay, so my answer here is x being equal to 3 over 8. So definitely that was the most tricky question from those examples. Okay, sorry, the sun is beaming in my face. Hopefully that was useful though. And of course, any questions, please comment in the comments below. Okay, thank you.